Hi, this is Dr. Graves back with part 2 of a tutorial designed to help students get started using and calculating descriptive statistics in Microsoft Excel. So let's go ahead and get started. I'm going to minimize or drag off the GIS that I have, and what I want you to take a look at data on this sheet includes basically the same data that we calculated manually. One of the things that I want to do right away is to do our first visualization with the data. I want to show you how to create a basic histogram, which is an extremely useful visual device to help one understand the characteristic of the statistics that we have calculated. So how do we do that? Well, what I want you to do is to put your cursor somewhere in column F and highlight the column, then select Insert, select this button here for histogram, and click OK. Now we're going to have to drag this down to the bottom of our data. And notice that it looks quite similar to this one because they're exactly the same. So I'm going to go ahead and delete this one. I double-clicked here and typed in number of tax returns. And when you click on the histogram or the graphic that you've created, note that a box here indicates the data that is being graphed. So the histogram tells us about the distribution of the data. Before I forget, one of the things you can do with this, if you click on it once, select copy, you can come over here to your Microsoft Word and right click, and you could paste it in as a picture, or you could paste it in with the source formatting, and once they're here you can sort of click and drag them and rotate them, do various things to put them in Word or other documents that you might want to create, like a PowerPoint or something. I'm going to go ahead and close this. What we have here is this histogram, and what it's showing us is the distribution of observation data. So we have 272 zip codes, and within it, each of these zip codes has this number in the blue box represents the number of tax returns. And so we have some zip codes that have a great number of tax returns, more than 47,000 total people filing a tax return. And then way over here on the left are this box represents those zip codes that have between 1,000 and 5,623 people in the zip code making a return. This you would recognize perhaps as the bell curve, and what I want to do is bring in a different piece of software. I'm a geographer, so I use ArcGIS Pro quite a bit. And what I've done is create essentially the same, I've recreated the same histogram using that software. The value of the visualization in this software is that I can visualize some of the other variables. The first of which is the mean. And so what this is saying is that on average, 16,865 people submit a tax return. The median, here in purple, just to the left, is 15,791. And there's the standard deviation, and they show up in these sort of gold bars. So we would say the mean is 16,865, give or take 8,679, which is to say that that is the standard deviation, and roughly 68% of observations, zip codes, would fall within one standard deviation above or below the mean. 68% of all zip codes had a number of tax returns that was, say, 8,679 fewer or greater than the mean. Interpret that as these zip codes are pretty normal because they are really close to the mean. A subsequent video to this goes into it a little bit more. What is interesting to note is that if we put the median back on here, it's a little bit to the left, which tells us that this data is slightly skewed on to the right. If I turn on this normal distribution curve, this shows a smoothed version of this, and that this tail over here on the right side of the red line is longer than it is to the left, and so you know that it has a bit of positive skewness. But this data isn't skewed much. This skewness figure here is less than 1, which is usually not something that would concern us moving on. This is a pretty good normal distribution. It follows the bell curve relatively closely. Now back over to Excel. If I move this histogram over to the right, and what I'm going to do is I'm just going to click on this blue box here, and I'm going to drag it over 1. So now the histogram reflects not really the number of tax returns, so I should take that off. It is the adjusted gross income per zip code. And so there are, especially if I make this extremely tall, that was really too tall, that was silly. But if I extend it, we can see that there are some zip codes over here. Let me sort it by adjusted gross income. Is that there are a few zip codes that have over $7 billion in adjusted gross income, and so that they show up way over here, or that this particular one shows up way over here. This not only drives the mean away from the median, but also increases the skewness. If I come over to the GIS software and change it, the variable being graphed, you can see it once again, and notice that the red line indicating the mean moves further away from the median, and this tail indicated by the normal distribution line extends far over to the right and not very far to the left. So that's even more skewing. Let's do one more here. Income per return. And the skewness number is even higher now. So much so that the high-end neighborhood, their income, some zip code has on average, their adjusted gross income is almost $1 million, $754,000, whereas the average neighborhood, the average income return is 90,857. So we're starting to get a great deal of skewness. And when we have that, we begin to worry about the quality of the data, or not necessarily the quality of it, but the utility of the data for other sorts of statistical analysis that we may do. There's nothing wrong with this. It just shows you that the rich are really rich and the rest of us are piled up over here in the towards the mean. I can do the same thing with the Excel data by grabbing this and dragging it over, sort of income per return. and we see once again the extreme skewing in the data. And the last one we'll look at is this variable which indicates the percentage of income that we pay, and it ranges from a low of less than 1%, 0.8%, to a maximum of about 12% of the income. So the percentage that one pays in taxes, or at least a neighborhood is paying in taxes, it ranges from less than 1% up to about 12%. And so we see this distribution on the histogram. Once again, if we replicate this in our GIS software, we see the bell curve. The mean and the median are reasonably close together, so this data isn't skewed much, but the standard deviation is wide and available on both sides of the mean. And so neighborhoods here are paying, are among those that are paying the least as a percentage, and they're mostly poor neighborhoods. And then these neighborhoods over, the neighborhoods that are over here on the right tail of the histogram are among those that pay the highest percentage of taxes. And as you can see, a lot of these are in neighborhoods that are wealthier, and so that's an indication that our tax system is progressive in California. Perhaps the fact that this tail isn't quite as skewed to the right indicates that maybe it is not as progressive as the income distribution itself. So, to conclude this, what you've gotten are a handful of statistical devices in your toolkit now that allows you to describe the distribution of data in a data set. The mean is important, the median is important, but the standard deviation helps you compare two different sets of data. I mean, we could have put, Shaquille O'Neal in a classroom and watched the way his addition to the data set, if we had everybody's height in the class, how he would skew that, how he would change the standard deviation. And so it's really useful and imperative that if you're going to do any kind of data work, to get a good grip on these basic descriptives first, so you understand the distribution of the data. Then you can note the outliers, how unusual the outliers are, or whether the data fits the bell curve. Well, I hope you've learned a little bit, and that there are follow-up videos to this where we use what we learned in this video to expand and build upon this basic foundation.